Okay, guys, sorry. Actually, my internet went off. Okay, okay, sorry. So back propagation here, it means that it is it is directly correlated. It is not directly, correlated to neural nets. Backpropagation is an independent term, and that is already been there in the field of mathematics. What he's telling here is that considering this expression, c equals to a plus b. Okay, the value of a is 4 and value of b is 2. Value of a is minus 4 and value of b is 2. Okay, and then there is a list of operations up till g. So what he tells is that we got the g. Okay, after performing n number of operations, we get the value of g. Okay, this is the a, this is the b, and these are some expressions, and this is g value. This is g value. Okay, and what backward propagation means is it will go backward to each of the operations and up till a and b. Okay, that is what I understood. Now, if I just this tensors. Tensors, what I think is they are weights. Yeah. This is the thing what I want. So Andrej Karapathy used the word tensor, and I have come across that there is this extension called dot safe tensors. I want to eventually go to drill down to that what does actually this tensor mean. So this part, it says that, you know, tensor is a new terminology to categorize scalars, vectors, and matrices. So scalar is nothing, some sort of, single digit number. So it can be, labeled as a tensor of rank zero. Then there is a list of number. Let's say if you have a list of numbers 1, 2, 3, then it can be that vector can be labeled as a tensor of rank one. Okay. If you have a matrix, 2D matrix, then that can be labeled as a tensor of rank 2. Okay, if you stack multiple 2D matrices together, you get a rank 3. For example, this is a rank 2 matrices, 2 with each row and column. Okay, okay. Suppose we are working with a data set of grayscale images. Each image is 28 cross 28 pixels. Here's how tensors come into play. Okay, we have a data set. Okay, data set. Each image has 28 cross 28 pixels. So this is the image, this is the image, this is the image, this is the grayscale images. Single image. A grayscale image is a 2D tensor of shape 28 cross 28. Okay, each number represents the integer of 0 to 1 and this. Okay, batch of images. A grayscale image is a 2D tensor of shape. 2D tensor. 2D tensor was this one, right? This one. Where it is? Yeah, this one. If we process 32 images at a time, we form a batch. This batch is a 3D tensor with 32, 28, 28. Yeah. Okay. Okay. Color. If the images are in RGB, each pixel has three values. RGB, a single RGB is a 3D tensor of shape 28, 23, and a batch of 4D 32, 20, 23. Okay, yeah. Examples, tensor in neural network computation. Let's consider a simple feed-forward neural network with input layer 28 cross 28, that is 784 neurons. Hidden layer has 128 neurons. Output layer has 10 neurons. Input tensor, each input is a tensor of 784 neurons. A batch of 30 is 32, 784. Yes. Okay. The weight transfer, the weights between the input are stored as a 2D tensor 784. Connect with this. Okay. During for one, that is input is 32, 7 and weights is 784. Result is 32, 128, representing the activation of 1. Example in this code. I didn't get it. Tensors are like multi-dimensional boxes that hold numbers. Depending on how many directions the boxes, we get different type of tensor. A single number like the no sides, no just one value. Vector has a direction associated with it. A list of numbers like a row of lockers, each holding one item, it has one side. A grid of numbers like a chessboard where each square is a number, it has two sides, rows and column. A stack of grids like a stack of chessboard on a row or a cubic where each layer unfolds numbers, it has more sides like length, height, with an analogy. A stack of pizza box. Think of tensors as stacks of pizza boxes where each box and its contents represent data. Means I don't know. Uh, that is scalar. Imagine if you have just one slice of pizza. It's a single piece of data, nothing else. Okay, now think of a for vector one dimension. Now think of a single pizza box with slices of pizza arranged in a row. Each slice represent a piece of data. This is one dimensional connection. Okay, okay. So there is a pizza. Okay. So the first box has only one size, one pizza, so it's a just single data point. Then there's another box. It is in rectangular shape. The first box was also in rectangular shape, but the pizza slice was only one, so that's why a single data point. They have arranged in this. So next, imagine you have pizza divided into rows and columns of slices. It's like a chessboard where each square is a slice. This is a grade of data or a matrix. Okay, we have grade now. Now picture a stack of pizza boxes where each box is a 2D pizza grid. Okay, okay. The stacks represent 3D tensor which layer with layers of grid. Okay, understood, understood. 4D, imagine you are managing a pizza delivery system with multiple stacks of pizza boxes where each stack belongs to a different customer. Now you have batches of pizza stacks. This represents a 4D tensor. Pizza delivery system with multiple stacks of pizza boxes where each stack now your best page. Acha, okay, okay. Real world image example. Let's tie this HANA to real data. Single image. A single grayscale image is like a 2D pizza that has rows and column. Each pixel is a number. Okay, yeah. Batches of images. It's like a stack of pizzas. Each image is a pizza and the stack forms a 3D tensor. Yeah, understood. Colored image is like a pizza with 3 layers. Oh, whoa, 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 whoa. One for red, one for green, one for blue. This makes a 3D tensor height, width, and color. Yeah, understood. Simple analogy using Python and pizza analogy. Okay. Import numpy as np. So this numpy is a library, guys. Okay. So and this np is a function. It's a method of that library. It's a tool of that library. Okay. Numpy is a toolbox. Np is a tool. Okay. So there is a single pizza. Let's say pizza equals to np random dot random. It is 28 cross 28. Bring single pizza images. Should I? Let's just do this. What is a grayscale images? Let me just go that. What is a grayscale image? A gray digital that contains only shades of gray, black, and white. Oh, acha. Each pixel is gray. Okay. Grayscale is often used by converting a full color image to a single channel image. Each pixel is represented by single by between 0 and white. Eh? Easy to understand and than full color images are often used in a higher resolution. Okay. What is the difference between hmm, grayscale is an image where the only colors are shades of gray are usually acha, acha. Okay, that is 0 to 255. Okay, 0 is the darkest and 255 is the full brightest, right? That is why 0 to 255. I'll just open up this Excel draw. But why tensors then? So let's say we have a pizza box like this. Okay, it has only one pizza. Considering we have gray only. Okay, grayscale images. Okay, this is a 1D tensor. Okay. Now you have a pizza box that has this much pizzas arranged in a row manner. This is 2D tensor. Okay. Now you have this pizza box in which the pizza slices are arranged in a row as well as columns. Okay. This is 3D tensor. Okay. Now for 4D tensor, this 3D tensors, I'll just I'll be able to if I do this and this, 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 this. Okay. If I select this, these are 4D tensors. They are arranged on top of this. Arranged on top of this. That is, they are 4D tensor. Okay. Let me just go. Grayscale image has 20 gate growth, that is its height and width is this. That is, this is 2D image, 2D tensor. And hmm, colored pizza means it has the pizza will have three layers. 32. But why? Let me just ask this question. Tensors are just containers for data. Okay. Scalars are single value, vectors are one. So tensors are like boxes. Huh. So this one here is called a tensor. Tensors are just for containers for data, single one vectors and using a so tensors are like the pizza box. Yes, you can think a tensor is a pizza that can hold your data. Let me define the pizza. Tensor pizza raw boxes. Okay, 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 I got it. But why do we need? But why there was a to need of tensors in the world is because they are powerful, axial, efficient tools for organizing, processing large amount of data. That neural networks work to handle real world data. Often a multiple images, height, width, income, all and height, width, this, order, this. time frequency channels, word sentences, paragraphs. Okay. Tensor can represent the data structures naturally. In grayscale images, there's height and width. Color there are height, width, and channels. For batch of color, batch, height, with channels. For efficient mathematical network million ones such as this. Okay. Tensors are designed to work seamlessly with this operation. One like TensorFlow and PyTorch use tensor that use CPU to generate data representation selection. Okay. Okay. So tensors are like boxes, and if we have to perform any operations on objects, like a real world object, we need boxes, right? Then only you will be able to do, transportation and so yeah, you can think of them, think of these tensors as this sort of boxes. Yeah, yeah. Let's just, this, it has provided us good explanation. To generalize data represented to work with bad nature of these are the examples. Okay, these are the benefits to fit hard. To work with efficiency, for example, instead of using one image at a time, a batch of 30 is processed together. Yeah. So yeah, instead of delivering a single piece of slice, a batch of three boxes, pizza boxes can be delivered together at the same location. Yeah. Model relies on GPUs and receivers are optimized for tensor operations. GPUs are designed for performing matrix and tensor computation very quickly. Tensor cores in GPUs and TPUs are, what is TPU? Are specialized in handling tensor data efficiently. Okay. Simplifying and code abstraction. Before tensors, programmers had to manually handle data and computations looping over arrays and matrices. Yeah, this is a thing. Yeah, this is the thing. Okay. So, matlab, before tensors, okay, before boxes, programmers had to manually handle data and computation. So, pizza slices had to be delivered manually by with hands. Okay, you can consider hand as an operations of array and matrices. High level abstraction tensors let you think about data at a conceptual level without worrying about low level details. Easy operations frameworks like TensorFlow and PyTorch allow tensor operations with simple and intuitive code. Import NumPy as co-np. Uh, Patch np.random this. That is okay. Flatten the images. Define random bits for with output. Multiply this. Okay, without video name. Best do this. हाँ तो मेरे को you tell me if you only had loose pizza slices, keeping them organized would be chaotic. Pizza whether it's a single box, a stack of box, tensor is easy to handle. Yeah, this is nice. This is nice actually. But yeah, if it is okay, to just tell me the above example would have been if tensors were not there. Above, nahi, below. You would need to manually handle organized data using nested loops and low level, no built-in challenging. Okay, but I need a code, bro. Okay, fuck, man. No cursing. Okay, so we would use nested loops to create and manage the batches or the list. Import random batch equals to random.random for in range of 28 for in range or for in range of this. Okay, so this is to create batches. Then flattening would require looping through each image and converting to the 2D grid into 2D one list. Okay, flattening means looping through each and converting the 2D grid into list. Define weights. We would manually create a list of weights for the layer of this. Okay. Perform matrix calculation looping over this. Oh, I'm not able to understand this. Okay. I don't know. I'm not going to into much deeper level, but we got the word. Okay, why tensors were used? Because uh, they hold data points, you know, effectively, and we can perform operations on them. But this is not their USP. Their USP is that they can hold any dimensional data points, be it 1D, 2D, 3D, 4D, any sort of thing. They will stay, good for operations and all. Okay, that is now just one last question. You know, the question from all of this were invented. What are safe tensors? What are safe tensors file then? Uh, I see this as I see this a lot as an extension to the model weights. Model weights in the hugging face. Hugging face. You know what hugging means in Gujarati? As an extension of to model in the hugging face. Say it is specific format for storing tensors like in a safe, efficient, and immutable way. It is commonly used in machine learning, including Hugging Face, to securely store and load large tensor data format. What a safe tensor is a binary file format designed for this, weighting weights of neural network embeddings or any other tensor-like structures. Acha, acha. Uh, Safety program measures code after efficiency, fast loading, saying without the overhead of parsing large human readable like JSON or plain text. Okay, so okay. Safe tense addresses some key issues with that exist with other formats like PyTorch.pt. Key address is PyTorch.pt and pickle file. Formats like PyTorch, PT, or pickle file can include arbitrary path and code, which could be dangerous if someone inject malicious code into the file. Safeties are immutable and contains non-executable code, making the speed. Okay, cross-command write uses in this how safe tensors work. So it contains tensor data, raw file data. So model like this example which is save tensors file using this model as pp install save tensors from save file. Acha import. Okay, is a secure fast way to store and load tensors. Okay, so that is an it's a method. Okay, to store tensors, data points in short, weights. Okay, so yeah, this is a good analogy. I will write, structure about this. I'll just can I can I rename this? What are tensors in? I'll just add copy this link. Okay, and add this. This is when it's I'm no कब बोला था यार ये बंदा ah at 5:54 at 5:54 and dimensional tensors. Okay, what are tensors in neural networks? मेंशन कर दे हाँ ये जो है ना बात Okay, so I'll just rewind 10 or 20 seconds back and see what does he actually mean. What does this does he say? Pedagogical? Pedagogical. Wow. Pedagogical. Relating to teaching. Whoa, bro, then use teaching. No. Bro, use, you can just say that it is used for teaching reasons. Pedagogical, man. It seems some sort of Jurassic Park term. Hmm. Understood. Yeah. Yeah. Okay. Okay. Now I understood the word tensor. What does he actually mean here is that this small values of -4 or 2, any sort of integers, these are scalars. These are scalars means these are, they don't have any other value other than this. It's like single piece of pizza. There is no data point, there is no direction or anything related to this. It's just a single point in an should I go technical? Yeah, it's just a single point in a space, it doesn't have any value of its own. So it does have any value, but it is not dependent of any other value. It does not have any direction and all of that. Okay, it's just a data point in a space. That is -2. You can consider as a -2, -4 is a small point, 2 is a relatively bigger point, 10 is a relative more bigger point in the space. You can consider that. But they are a point, no length, nothing. So you can tell them as a scalar values. Okay. So what he is telling here is that this uh, this scalar values used here are for pedagogical reasons. It means that this is just for teaching purpose. Because when in real life scenarios, obviously you'll have more dimensional values to work with. So here this micrograd does work with the scalars also, and does work with n-dimensional vector, the n-dimensional values. Okay, n-dimensional weights, which are also known as tensors. Tensors means different types of boxes, pizza boxes. Pizza boxes means a pizza box can contain one slice, then it will be a one-dimensional tensor. A pizza box contain a series of pizzas arranged in a row, then it will be a sorry, this will be a one-dimensional. Before one was a zero-dimensional tensor. Okay, then again a pizza box in which the slices are arranged as a row-wise manner and a column-wise manner, then it will be a two-dimensional manner. Okay, then again this pizza slice are they are if they are stacked on each other, that is a three-dimensional pizza. Then if this pizza slice has three layers of cheese burst, toppings and some sort of oregano or some sort of sauce, then itself it is a four. Okay, I'll just go through that. Where it is? Where is it? No, this is say of tensors. So the 3D one is this one, which is if you have three layers, then it is a 3D tensor. But if there is a stacking of these boxes on each other, then it is a 4D tensor. Okay. Yeah. Okay. Understood. Understood. This is the thing. Okay. But what if? Let me just then. No, no, yeah, I'm not able to understand this. Just give me 2 minutes. Uh, 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 uh. Summarize the conversation. Maintaining the important points to understand. Important points required to understand tenses. Hmm. Tenses are like these are represented boxes. Acha. So boxes is layers. Okay. Represent harder like batch of pizza. Without tensors, they take up. In this summary, add more related to the pizza analogy. Slices represent individual data values. Tensors are like pizza following. Slices are not their data value. Boxes, the organized structure, format, structure, boxes, the single image. For example, like they say like one pizza box where is pizza batch. A batch of images is like stacking 32 pizza boxes and representing one image, an image. Uh, okay, I understood. Man. This guy is hallucinating now. Okay. So not hallucinating, but it's not giving me the proper explanation. Uh, and let me just reiterate what does tensor mean. So I'll be going with this same example of pizza. So first of all, imagine a world where there was no box invented. Okay. So how are you going to store the data, store the pizza, right? How are you going to perform some operations on this pizza? Operations like you want to transport it to someone else. You want to transport this pizza to a customer. Okay. So for now, now to transport this, you need something, no? You need something, you need a structure that can that can that is efficient enough to perform operations in every scenario. Let's say you want to if let's say if you have a box, you can transport this, you can put put this pizza slice in that box and give it to a customer that is present in your restaurant right now. Okay, you can put this slice in the box and send to a customer that is 50 miles away from your restaurant. Okay, these are different operations. So how these operations got enabled? Just because the box. Now, this is one dimensional. Okay, zero dimensional because there is no pizza, only a single point, a single data point, a single scalar value of one pizza is there, one pizza slice is there. That is what is that box is called zeroth dimensional tensor. Okay. Now, if I have a box that has 10 slices in a row, then that box will be called as one dimensional tensor. Okay. If I have a box that has 10 slices of pizza arranged horizontally and 5 columns, then it is called two-dimensional tensor. That is 10 cross 5 dimensional. That is 2D dimensional tensor. Now, if I have uh, if I have let's say the pizza itself has 3 layers of cheese burst, then sauces, and then toppings. Okay, these 3 layers are there. Then this box will be called as three-dimensional tensor. Why? Because it has 10 cross 5 slices, where each slice itself has 3 layers. That is why it is called three-dimensional tensor. Now, all this, let's say this three-dimensional layer, if I stack them on each other, okay, this, then this whole thing is called four-dimensional tensor. Okay. Why this four-dimensional tensors and all of this boxes? Why boxes are important? Is because we will have that flexibility to perform operations. I have two stacks. Okay, I have two stacks of four-dimensional tensors, and I want to add two boxes from this one to this one. Then it will be easier for me. Okay, now imagine a scenario like there was no box present. It's just a pizza slices only. You have pizza slices here, also pizza slices. Okay, then you won't be able to. It would be tough for you, no, to manage this, right? That is why the box is important. To it is like they are containers. They are containers that hold the data points, and which helps us to manipulate for manipulating them with operations and all that stuff. This is the understanding that I got. Okay, this is tensors. Now, what is safe tensors? So safe tensor is an extension to store these tensors. Okay, it is just an format. It is a file format for securely storing this tensor. You can say that this as a cold storage room. Okay, cold storage room in a pizza box in a pizza factory, where the characteristic of this room is like, if you want to store pizza boxes, then you need to store them in this particular refrigerator, or yeah, you can tell it as a refrigerator. Okay, so that the pizza does not get degraded by the temperature decrement or increment. Okay, so you can consider them as that. Binary files for securing reference and data. That is image. This is for safety, speed, cross compatibility. You can put them. Okay, put them all this tensor file in one refrigerator and send it to your another franchise that is in some another town. So you can tell that I'll be sending this in the safe tensors file. Okay, that is clear. I guess we have reached the stopwatch. Let me just, so what we understood is we just went to this only, this third, we understood what are libraries and while encoding, and what are tensors and say neural networks. So I guess that's it, boys, for today. We have gone through this only 5 or 5.858, that is 6 minutes of Andrej Karapathy's video. But yeah, we cleared our foundational knowledge, like what are tensors, what is library. Okay, so yeah, that's it for today. Uh, I will be coming back tomorrow. We'll start from this only 558, and yeah, we'll keep learning in this manner. I know it's tough. It's tough for you guys. Some of you guys will find by this pace you will be how long you will it will take for you to understand this. But yeah, this is what I feel about this is that this is one of the approach that that AI or generative AI has enabled right now. Why? Because see, I know with this pace, five like in 1 hour we went through 6 or 10 minutes of a video, so it will take a long time. But exponentially, this time will get reduced. Let's say because now when in the future, let's say at 1 hour and 13 minutes, if this tensor word comes up in my mind, then I will have a clarity that the use case, this is why the tensors are used, this is why the safe tensors are used. Okay, so this approach, it's reluctant, it's very tough to follow in the beginning, uh but it keeps on decreasing afterwards. And that is and the main helper here is generative AI. I have not to search this topic and to get this much clarity in 5 or 10 minutes. It would have taken me a lot of computational uh, a lot of energy of me without this the chat GPT. Okay, but it has approached, it has explained me in a very simple manner. Okay, and now if I now that I have as a I and now as I have the analogy of pizza boxes, I would be remembering this tensor and model weights and all of that from my lifetime. Okay, so yeah, this is it does take a good amount of time, but we are building a good foundation. Okay, so thank you so much, guys. I'll be coming back here learning Mr. Andrej Karapathy's video. Okay, tomorrow. Bye. Bye.